Welcome to the MS&Me Radio Network. The broadcast shows are for informational and entertainment purposes only. They are not designed to provide listeners with specific personal, medical, or counseling advice. Individuals with a medical issue should always consult their healthcare provider. MS&Me is not responsible for content of individual shows. The views expressed by show hosts or their guests are their own. Enjoy the show.
I'm John Strum, and this is RealTalk MS. A special welcome to everyone now finding our podcast on MS&Me Radio. I'm thrilled to be invited to join the lineup, so now there's one more way for you to find Real Talk MS in addition to iTunes, Apple Podcast, Google Music Play, and Stitcher. And I want to thank so many of you who have found our podcast. This is our 2-month anniversary, so it doesn't seem very long at all, but already we're at about 2,000 downloads for each of our episodes, and that is absolutely amazing. So I thank you for listening, for talking about it, and for coming back for more. And this week's podcast is about how MS affects men and women differently. And my guest this week is Dr. Rhonda Voskul, who's a trailblazer in exploring the differences between the sexes in MS. But before we get to our conversation with Dr. Voskul, a few other things happened this past week. An outdated and arbitrary cap on how much outpatient therapy a Medicare beneficiary can receive each year, and that's regardless of medical necessity, has been in existence for the past 20 years. So to permanently repeal the flawed therapy cap policy, members of Congress have introduced the Medicare Access to Rehabilitation Services Act. Now, ending this cap will allow approximately 1 million Medicare beneficiaries access to medically necessary services that help people affected by MS live their best lives. So once again, I'm going to ask my listeners living in the U.S. to pick up the phone and call the U.S. Capitol Switchboard at area code 202-224-3121 and ask to speak to your congressional representative and your senator and let them know that we need their support for the Medicare Access to Rehabilitation Services Act. If you're a regular listener to the podcast, you should probably go ahead and put that phone number on speed dial, because one of my goals is to convince you that we are all activists when it comes to ensuring the best possible treatment and care for people affected by MS. We know that our phone calls are effective, and we know that there's strength in numbers. So being reminded to speak up on our own behalf is going to be a regular occurrence on the podcast. In last week's podcast, one of the things that we talked about was the role that gut bacteria might play in MS onset and progression. Well, researchers in Italy have published the results of a small pilot study that they did, and the study points to how our diet can affect our gut bacteria, which in turn will impact our multiple sclerosis. Now, first off, I want to stress that this was a pilot study with a very small number of participants, 20 to be exact. But I wanted to share it with you because I think the results from this small sample of participants almost require that the study be replicated and expanded to a broader population, because they came up with some really interesting information. Now, the 20 participants had all been diagnosed with relapsing remitting MS, and they were all attending the Multiple Sclerosis Rehabilitation Unit of the Don Carlo Gnocchi Foundation in Milan, Italy. The 20 participants were divided into 2 groups of 10, and one group was placed on a pretty standard Western diet that included regular consumption of red meat, processed meat, refined grains, sweetened foods, salt, and a high intake of saturated and omega-6 fatty acids. The other group was placed on a high vegetable, low protein diet, and both groups stayed on these diets for 1 year, and at the end of a year, The researchers found that the gut bacteria of the patients in each group changed according to their diet. The patients on the high vegetable and low protein diet saw their gut bacteria enriched by a bacteria called, are you ready, lactospiricae. And lactospiricae produce a compound called butyrate, which has been suggested to reduce inflammation and promote greater immune tolerance. Now, the other group of patients on the Western diet showed an increase in a different bacteria, and this bacteria has previously been shown to be associated with shorter time between MS relapses in pediatric MS patients. In addition, the patient group that was on the high vegetable and low protein diet showed a significant reduction in their MS relapse rate and in their expanded disability status score. So these are some pretty significant outcomes for this small pilot study. Hopefully, we'll see the study expanded to a larger population because it would at least appear that diet can be used as a tool to modulate your immune system in a way that would reduce inflammation, reduce relapses, and limit disability. The final chapter in a somewhat scandalous story about a treatment that was touted by its creator as an effective cure for MS has finally been written, and the treatment has been completely debunked, and the person who finally did the debunking was its creator. So to understand a little bit about this story, let me take you back to the year 2009, when an Italian physician named Paolo Zamboni advanced the theory that multiple sclerosis damaged the central nervous system because blood was pooling in the brain due to inadequate drainage. So he called this condition chronic cerebrospinal venous insufficiency, or as it became known, CCVI. And Dr. Zamboni claimed to have a cure for this condition. He suggested inserting stents, which are designed to hold arteries open, into veins in the neck to increase the blood drainage and therefore resolve the symptoms that were due to MS. He dubbed his treatment the Liberation Treatment, and almost overnight, MS patients throughout North America and elsewhere were demanding the Liberation Treatment, while most of their neurologists were trying to explain that it probably wasn't going to work. They tried pointing out that Dr. Zamboni's study that he used to prove his theory was just riddled with serious flaws. But the media picked up on CCVI, and this created a feeding frenzy among people with MS who were desperately looking for an effective treatment. And if neurologists weren't willing to perform this so-called treatment, CCVI clinics were springing up in Poland and Costa Rica and India and elsewhere. Meanwhile, the MS societies in the United States and Canada were both investing significant time, effort, and money trying to test Dr. Zamboni's claims by applying the kind of strict clinical protocols that Dr. Zamboni hadn't really bothered with. And in study after study, Dr. Zamboni's Liberation Treatment was shown to fail. And finally, in this month's issue of the Journal of the American Medical Association Neurology, Dr. Zamboni himself has published the results of a clinical trial that he and other researchers pursued using all of the appropriate protocols that should have been used originally. And in his paper, Dr. Zamboni has concluded that his Liberation Treatment does not cure or even mitigate MS symptoms. He brands his treatment, quote, a largely ineffective technique, and says that it should not be recommended to MS patients. And so after so much money has been spent, and so many hopes have been raised and then crushed, Zamboni's Liberation Treatment joins hyperbaric chambers, snake venom, and other failed MS therapies that created media-fueled sensations but never really cured anything. In a moment, I'm going to be joined by my guest, Dr. Rhonda Voskuhl, and we're going to be talking about the differences between men and women when it comes to MS. My guest today is Dr. Rhonda Voskul, the director of the Multiple Sclerosis Program at UCLA, and the Jack H. Skirball Professor of Multiple Sclerosis Research. And we're talking about gender differences in MS. And this is such an interesting and important topic because MS is a disease where the difference between men and women is pretty glaring. Women tend to be somewhere around 3 times more likely to get MS, but men often develop more significant disabilities from MS. So welcome to the podcast, Dr. Voskul. Thanks so much for joining us today.
Thank you for having me.
You know, if we go back in time a little bit, about 25 years ago to your days as a postdoctoral fellow, the scientific community didn't seem overly interested in understanding why diseases behave differently in men and women. But last year, when the National Institutes of Health announced a new requirement that all NIH-funded preclinical studies include males and females, they cited your findings in sex differences in MS as a rationale for their new policy. So it seems that a lot's changed over the past couple of decades, and a lot of that change is due to your work. I'm curious about what initially interested you in looking at sex differences in multiple sclerosis.
My view is that diseases are very difficult to understand, and any clue that we can get from naturally occurring things that happen that could lead us to new treatments would be the way to go. It's called bedside to bench to bedside. So instead of starting with a molecule of interest that may or may not be important in a disease, I think it's better to start with the clinical observation that is clearly true in a disease, and then try to figure that out at the laboratory bench and find the molecules, and then turn that into hopefully a clinical trial. So I view the sex difference as a major insight into the disease. And as you said, there are two major insights within that, and that is it can tell us why the fact that females get the disease so much more frequently than males do probably is related to something with the immune system. And by the same token, the fact that when men get MS, they do worse could tell us a whole lot about the way the brain reacts to an immune injury. So I view these things as clinical observations that are extremely important, and if we could just figure them out, we would have some real inroads into not only understanding the disease, but to develop some treatments to reverse these processes.
Well, one of the observations that an awful lot of people seem to make is that during pregnancy, women with MS have fewer relapses and they tend to feel better than they usually do. Why is that?
That's a very good question. And so the way we viewed it was to say, well, when does this happen? And when it happens actually is the third trimester, or even the last half of pregnancy. Women feel great. Their symptoms feel very good. The relapse rates are reduced more than any of the drugs available currently. And so, again, we said if we could just figure this out, maybe we would really have something. And so what we did is we went one by one looking at the factors that occur not early during pregnancy when there's really not that much of an effect, but late in pregnancy when we know there's this dramatic protection from the disease. And so when we looked late, we focused on hormones that tend to be very high during late pregnancy, and then interestingly, they drop abruptly after the woman delivers. So those hormones involved estradiol, which is the classic estrogen that's there during the ovulatory cycle, of course, at much lower levels that are fluctuating with the cycle. Progesterone, which is also made during the menstrual cycle, but a really interesting other estrogen called estriol. Estriol is not there usually when women are not pregnant because it's made by the fetal placental unit. And all estrogens are not alike. So this particular estrogen is extremely safe. It's safer than the other estrogens because it binds to a receptor that doesn't cause deleterious side effects. And what we wanted to do is we said we may not understand all the reasons, but let's just stick to as close as we can to late pregnancy. Since estriol was the hormone of late pregnancy and not there otherwise, we thought there must be something about this particular estrogen that is probably mediating the protection. So we went to the animal model and we tried each one of these things. And progesterone in our hands didn't do too much to the MS model, but estradiol and estriol were both extremely very protective. They both reduce the immune attack as well as, and this is importantly, as well as bind to cells within the brain to make them more resilient so that they don't undergo degeneration, and also in some cases cause them to repair and cause remyelination and sparing of nerves. Now with respect to estradiol versus estriol, the two different estrogens, we like estriol better because it's the estrogen of pregnancy, but also because estriol is so much safer than estradiol. It's even safer than estradiol as used in, say, birth control pills or HRT. Estriol is extremely safe, and it's going to be very well tolerated and something that people could take for many years. So that's why we now have done 3 phase 2 clinical trials of estriol in multiple sclerosis, giving a dose, of course, that recapitulates a pregnancy level in the patient's blood.
And it sounds that like the outcome of those trials has been pretty positive.
It has been. It actually couldn't be better. So with the first clinical trial that we did, it was a small pilot trial, and it was published in the Annals of Neurology, where we gave estriol, and the outcome measure was a biomarker, which is enhancing lesions on brain MRIs. We scanned people every month, and we saw that there was a 70 to 80% reduction in enhancing lesions. That was, of course, a big step forward to keep going. And so then we designed another trial, and this was at 16 sites across the United States, and it was published in 2016 in Lancet Neurology. This was also a phase 2 trial, but it was unique. It didn't have a biomarker as a primary outcome. It actually had a clinical FDA approvable outcome, namely relapses. And this is because the NIH funded it, and this is what they wanted. And so we had, as the primary outcome measure, a reduction in relapses, and as secondary or exploratory outcomes, the effect on cognition and effects on fatigue. And so we were extraordinarily happy to see that we hit our outcome as designed. It was 164 patients, half were treated with placebo and half with estriol. We added it on to Copaxone, by the way, because we needed to give all the patients standard of care, which is an MS drug, Copaxone. And so over and above what Copaxone does for MS, we reduced relapses further as designed and hit our outcome, and in addition saw beneficial hints that there might also be something going on with improving cognition, which is also extremely exciting and consistent with previous work about estrogens being neuroprotective and being good for cognition. So now what we've done is we have done 3 things. We have designed another clinical trial that is actually almost done enrolling. We can take about 3 more patients, so if somebody's out there, just email me or contact UCLA MS program. And that is now having cognition as the primary outcome measure. So now we're enrolling patients specifically for the cognitive outcome. It'll be done enrolling in about a month or 2, and then they'll take drugs for about a year. Well, it'll be 12 months exactly, either estriol or placebo. And we'll see with cognition as a primary, whether we can see that improvement in cognition. Notably, this is not a decline in loss of cognition, but is actually making people who have cognitive decline and making them better. So there aren't very many drugs out there in Alzheimer's or MS or anywhere else which you actually see improvement. Most drugs will slow degeneration, but not very many at all will cause actually improvement or recovery or repair from some of these disabilities. The other thing that we've done, in addition to having this third trial, the second one on cognition, now almost done enrolling, is we had Quintiles, which is a global CRO, do a third-party analysis of our Lancet Neurology paper results, and they validated that. That's important because that's the next step for planning a phase 3 trial of estriol, which we're now in the stages of doing, and have just received another grant, which there's going to be a press release in a month or 2, but I don't want to say it's anonymous, but we now have a planning grant to plan a phase 3 trial of estriol, and it'll be global in its nature. So we're extremely excited, and we're pushing forward. It's a very unusual situation, of course, not to have a pharmaceutical company doing this, but for us to be doing it as an academic with nonprofits.
I'm glad you brought that up, because as you're talking, I mean, you're getting me excited about the prospects here. But I'm wondering, given the fact that we're dealing with a hormone and a pharmaceutical company, assuming they can't patent that, how difficult is it to get their buy-in to be able to take this to the step of creating a practical therapy down the road?
It's been the biggest hurdle we've had. I think that if there's a drug out there that is straightforward, it's going to be hard. If it's not a patent-protected drug where it's a secret molecule, those are much easier. Big pharmaceutical companies love those because they can get a patent on them, and it's a secret. It's easy to control it. We do have, the other thing we're doing is we have already developed the next generation estriol, which is a pure E beta ligand that goes to the brain and it stays there, and that's going to be an easy cell, of course, because it's a secret on the chemistry of how we're doing that. But estriol itself is difficult because it's a biologic. It's something that It's not a secret about what it is. The only thing that we have, which is worthwhile, I shouldn't say only, but UCLA, we have a patent which is the dose of estriol and the dose of the progesterone and how you would take it and how you would package it. So we do have a patent around, I guess, new use for an old drug and how to do it and what the progesterone with it would be and to make a convenience sort of a situation out of it. But no, it's not a secret, and that makes it extraordinarily difficult.
This is both exciting and potentially a little frustrating too. And if I'm feeling that, I can only imagine that's something that you've lived with far longer than I. But
I have, and I think it's a concern for actually drug development. I really do. I think that it's a shame how many things that academics and physicians come up with that are really good ideas. And, we're not thinking about, starting companies. We're just not. This kind of like, it's not our expertise, but you just wonder how many things people just get frustrated. But I'm not going to stop because I know that it works and I know that it's safe. And so, we are going to develop, we've developed the next generation estriol, and it's a secret, it's a chemical, and that's fine, but I'm not going to walk away from something that I know has already been given in multiple trials, and it's been given for HRT, for hot flashes in Europe and Asia. I know it's safe, and so I just can't walk away from something that I know that works and is safe.
And I bet an awful lot of people listening to this are incredibly glad to hear you say that too. I so appreciate you taking the time to walk us through something that I think is really exciting. There aren't a lot of people who are dealing with MS therapies that can say it works and it's safe, and you've said that 3 or 4 times already. So I only look forward to the next time we get to talk, maybe once your phase 3 is rolling or concluded. And I really look forward to hearing the next steps taken in this particular realm. It sounds incredibly promising.
Yeah, I would like to say something good about the NIH. I think they've gotten a lot of, there's two ways to look at trying to do sex differences work in both females and males. I think it's extremely important. Of course I do, but it's really a win-win. Let me put it this way. If an investigator has a finding, whether it's cardiology or neuroscience or whatever it is, and they do it in just one sex, and they don't know whether it extends to the other sex or not, that's just so important because either one or two things can happen. Either they repeat the study in the other sex, and it's true, and then they say, wonderful, great, now we have something that works in everybody and we're real happy about it, so they extend their findings, A. Or B, what happens is it doesn't extend. And that's extremely important to know that, a dose or a drug works in one sex and it doesn't work in the other. That's extremely important clinically to know. So I think the NIH is to be commended on pushing forward with this. And of course, the major thing is that when you look at the differences, sometimes you find something really interesting that can be dissected through and come up with a new treatment.
You're right. It sounds really important. I'm glad they saw it your way. And I'm glad it was your work that actually caused them to pay attention. The way you explain it, the logic is just crystal clear. It makes all the sense in the world to go ahead and test and do studies, both male and female. Otherwise, you're right. You have half an answer, and you really don't know which half is the right half. So
that's
makes sense.
Exactly right.
Makes sense. Dr. Vespel, thank you so much for taking the time to speak with us today. I so appreciate it.
Thank you.
And that's going to wrap up this episode of Real Talk MS. My name is John Strum. Thanks again for listening, and we'll catch you next time.